Hi, I'm Ryan Daws, Senior Editor at TechForge Media, and joining me today is Alessandro Grande, who is the Head of Product at Edge Impulse. So, Alessandro, what are some of the challenges of developing machine learning models for edge devices?
Thank you. It's a really interesting questions. We are seeing a lot of companies struggle with the data set. So the first thing that all companies need to figure out is really what data is enough. What data should they collect? What data from which sensors should they collect the data from? And that's a big struggle. And the reason for that being a struggle is that a lot of the companies building edge devices are not very familiar with machine learning. So that comes with the second struggle or the second challenge, and it's really talent or expertise effectively. We're seeing a lot of companies effectively being experts in IoT or embedded, but not being so familiar with the data world. And bringing those two worlds together is the third challenge really around having teams communicate with each other and being able to share knowledge and work towards the same goals. So I would say those three are the main struggles that we're seeing.
Excellent. And so, how do you optimize models for on-device performance, memory footprint, and latency?
It comes in, I would say it's a three-step approach at least. So the first thing you need to think about is really what is again, going back to the data problem, what is the minimum set of data points or minimum set of sensors that I can collect data from that will give me the right output that I'm looking for, right? So, for example, if I'm trying to detect a glass breaking, right? Do I need a camera or is it enough to have a microphone, right? And if it's enough to have a microphone, that will probably require less computing than if I'm trying to compute images. So that's the first way of kind of thinking, or the first thing that companies need to think about. Second one is really around what model architecture do I choose, right? And do I choose a combination of model architectures? Do I choose doing feature extraction prior to doing the model, or do I just let the model do the feature extraction itself? In a lot of cases, actually, doing the feature extraction as a separate step reduces the footprint of the model and the efficiency of the model running on the device. And the third point is really around techniques for improving the size of the model or kind of reducing the footprint of the model. Quantization, for example, is a big technique where you can quantize most of the weights and the activation functions to 8 bits instead of using the 16 or 32 bits of the typical mathematics in a chip. That reduces the footprint by a lot, and it improves the speed at which the computation happens as well.
Excellent answer. So, what are some of the trade-offs you have to consider when tuning your models?
Trade-offs, it's an interesting perspective. I think it comes down to really, again, what kind of sensors do I have, right? Like what kind of sensors do I have available to me, but also what kind of sensors do I choose to use, right? That's one aspect. And then the next one would be, what is the minimum viable hardware that I can deploy this model to? Do I need a bigger hardware because perhaps I have, for example, connectivity that I need to deal with, right? So do I need more memory footprint because I actually need to run a bigger software stack? In which case I might have a bigger hardware available, and of that I might use memory, as part of that memory for the model. So it really comes down to what kind of hardware do I have available, and what kind of sensors do I use to build that model, and then kind of interpret the world around the device itself.
Great. And so, how does Edge Impulse ensure the accuracy and reliability of its models?
So Edge Impulse enables developers to do that themselves, actually. So we are an engineering tool. I always like to say that we're not a silver bullet. ML in general, or AI, is not a silver bullet. We are providing an engineering tool that enables customers to look through the data themselves, look through the model, and effectively verify that the model is performing correctly based on certain parameters, certain metrics that we provide, typical ML metrics that ML engineers are familiar with. In the case of Edge Impulse, we're also trying to make it easier for people that are not familiar with the ML world, right? So we're trying to target both the AI savvy world, right? People that are experienced with AI and ML, and people that are not experienced. So embedded engineers, hardware engineers, firmware engineers, and enabling them to understand whether the model is going to perform accurately on the device. And I'll just add one last thing. We're trying to really reduce the cycle by the time it takes to actually deploy that model by kind of finding out if things are not going to perform correctly on the platform itself, without requiring the teams to deploy the models, because we know that once you deploy the model, there's a lot of other constraints or complications that come out from the fact that you're dealing with a hardware device now.
Yeah.
So we're trying to like really kind of help the engineers figure out what's wrong, what's not working in the platform itself, in Edge Impulse, before moving to the hardware.
Cool. And so delving into more how you work with developers and engineers, how do you integrate with existing machine learning workflows and tools?
Yeah, so we have a couple of ways to do that. First of all, we are agnostic to any cloud vendor, so we can bring in data from any cloud provider or any data lake, right? So there is no requirements on which data infrastructure you have. We are completely agnostic to that. So once the data comes in, we're able to run machine learning models, or enable effectively the development of machine learning models using typically PyTorch or TensorFlow, and that's familiar for all machine learning engineers. If a machine learning engineer already has a pipeline for developing their models outside of Edge Impulse, they're able to bring their model within Edge Impulse through a series of ways, through the UI or our Python SDK, effectively, to integrate directly Python calls within their own Jupyter notebooks, for example. Third way that we're able to integrate with their flows is through effectively the ability for them to use our analysis methodology effectively within their experiment tracking. So they can run, for example, an analysis of their model on a specific hardware device. So we're able to give them performance metrics that they can then use within their own experiment tracking infrastructure, for example, ML flow or weights and biases, and they can use those metrics to analyze effectively which model is best fit for the hardware device that they're targeting.
Great. And so are there any particularly interesting projects that Edge Impulse has worked on?
Yeah, there's quite a few. I'm actually really excited about a couple of projects in the health space. Reason being, they're wearables that everybody, most people can buy off the shelf now, and they're giving some really interesting insights into our lives, right? So one of them is Oura Ring. It's a ring that enables us to like figure out effectively whether you had a good sleep and what is your activity levels today, right? What are your activity levels today? How are you feeling today? And it kind of gives you a sense of what's your well-being effectively. And that's a really interesting one. It's sold over 1 million pieces, and it's it's something that everybody can experience and everybody could get a sense of really the power of Edge AI. Another one that's really interesting is a company we're working with, No Labs, that has been developing a non-invasive glucose monitoring system that is revolutionary in the sense that it allows users to monitor their glucose levels, diabetes patients, without any finger pricks or any other intrusive monitoring. So it really kind of enables a new generation of monitoring of glucose levels. And I'm really passionate about that because I think it doesn't really improve lives.
Definitely.
Right. And then on the industrial side, I think that's another big space where we're seeing a lot of traction. It's interesting that we're seeing a lot of use cases around visual inspection. So really the idea is around trying to understand whether there are anomalies in production lines, for example. I have a production line with certain things that are expected to be generated. Am I seeing anything anomalous? Can I flag anomalies quickly to the staff so they can go and monitor the actual production line, or even in some cases automate the production line to actually move away those items that need inspection or need fixing. So that's really interesting because it really enables augmenting flows that are flows that we've had for a while now, but really kind of improving efficiencies across the board.
Yeah, I mean, you've basically already answered my next question in that comprehensive answer. What are some of the biggest opportunities that you see for machine learning on edge devices?
It's an interesting question. I think there's obviously various angles, but it's something that it's really dear to my heart. I think it's really about, to me, the big the big thing that we're unlocking is really the ability for these devices to become more useful, right? I think we're all dealing with devices every day, right? And some of these devices are hard to use, complicated, frustrating, really dumb in some ways, right? And I'd love to see a world where the devices that we were dealing with less devices, first of all, right? And the devices that we're dealing with were actually more useful to us, right? So rather than giving us, a temperature, for example, right? Like I'm thinking about a thermometer. I don't want to just know what my temperature is. I want to know whether I'm actually sick or not, right?
Yeah.
If I'm setting an alarm, I don't want to just be woken up when I've set the alarm to. I would like to actually have the alarm being smart and perhaps like have a time range in which I'm okay to be waking up, and the system should decide, or should, based on the ability of it detecting whether I'm in light sleep, for example, be able to wake me up when I'm in light sleep, not when I'm in deep sleep, right? Within that time frame. So things like that, I think, could really improve our daily lives, right? And that's just general lives, right? Then there's all the workers' lives, and there's also really, in the medical context, there's a lot of improvements that could be done for patient monitoring, like we talked about glucose, for example, and there's a lot of other examples in that respect.
Yeah, I don't think I need to be told that I didn't sleep well last night. I know that, but if I can have some actionable insights on how to improve that, that will definitely help. Well, that's everything for me today, Alessandro. So thanks for coming along to speak to me.
Thank you very much.
Have a great rest of the event.
Thank you.